I just am scared shoving blue gack in between my keys.
I mean, you could just stop at shoving blue gack in between my, and I think whatever it is that comes next is appropriate.
Hello, everybody, and welcome to another episode of JavaScript Jabber. I am your host today, Steve Edwards, and joining me on our panel is Amy Knight.
Hey, from Nashville.
AJ O'Neill.
Yo, sunny Pleasant Grove.
Woohoo! Yeah, here in Portland, it's rainy and cold. It was great through Sunday, and then everything hit the fan. And our guest today is...
Victim is appropriate.
Victim, yes. He's returning for more punishment. And this is Joe Karlsson from MongoDB. Yay, Joe, how are you?
Yoo-hoo! Yeah, yoo-hoo from Minneapolis, Minnesota. It sounds like Minneapolis is the warmest city out of all y'all's, which is kind of surprising. But I'm so glad to be back. I'm shocked I wasn't permanently banned from this program. So thanks for having me back here.
Make people feel that way. But it's actually the shocker that I am not permanently banned from this program.
That's good.
Hey, we may get into a great street fight today. We'll see how that goes.
If you're a front-end developer looking for remote work, then I recommend G2I, a React and React Native focused hiring platform that will connect you directly with their clients that need your skill set. What makes G2I a unique hiring experience is that they spend the time marketing you to their clients of your choice. G2I is a team of engineers that technically vets you up front. If you pass their vetting, their clients have agreed to skip their initial interview process, saving you time and energy getting your next gig. They take care of all the hard work for you so you can get focused on development. To join G2I, go to g2i.co and apply.
Last time Joe was here, which was a few weeks ago, I lose track, they all run together. After a while, we were talking about IoT, the Internet of Things. But this time, we wanted to talk about MongoDB, which is Joe's specialty because he works for MongoDB.
Yeah. It turns out you learn a little bit about the tool from working at that company. Who knew?
Amazing how that works.
Yes.
So why don't you give us a litlittle bit intro again and your role at MongoDB, and we'll slide right into what you're going to talk about.
Yeah, absolutely. So obviously, I wouldn't be here if I wasn't a JavaScript Node fan. I've been programming, using it for forever. I love it. And I love teaching about it too. But I've been working at MongoDB now for about a year-ish. Not too long, but I've been a technical lead on some of the largest e-commerce sites in the world and kind of managed those and massive scalability issues with those too. I do developer advocacy at MongoDB, and which means I just get to teach people about databases or help them wherever they're at, right? So just kind of talking, hanging out, working on cool projects. Like last week, I was talking about my IoT kitty litter box, which I got paid to build, which I'm still blows my mind that that's a job that someone can do. I have a hard time explaining that to my parents sometimes, what I'm doing. Anyway, that's my job, work for MongoDB. I just get to talk about cool stuff I'm building.
All right. So you have a talk from NoSQL to NoSQL.
That's
a
right.
Gentle introduction for developers. So we're just going to sort of use that as a framework for today.
Yeah.
So why don't you start out and start walking through, and then we'll follow and discuss as things arise.
Yeah. So I guess for people tuning in today, I want this to be kind of a discussion for people who are, or this is going to be helpful for people who are just starting out with MongoDB, right? And a lot of people who have been building databases have probably, obviously you've probably heard of MongoDB. And if you've been building them, you've probably been using SQL. So we're going to be focusing on what MongoDB works like and looks like and how to use it compared to an SQL database. I also want to be talking about some of the advantages and disadvantages of using MongoDB compared to SQL. And I want to be talking about, this is probably the most important part, but what are the biggest mistakes I see developers making when they come from an SQL background to no SQL? Because I see a lot of people just trying to do a copy pasta, rows, columns, and tables, and then try to just jam that into a MongoDB database, which usually doesn't work that well. It may work fine for a little bit, but it doesn't scale well. So I'd love to talk about what those are. So everyone joining into, even if you've been using MongoDB for a while, I'm hoping you'll still get some new stuff out of it because you may have been using things incorrectly, and hopefully I can start pointing you in the right direction.
This is where I'm going to get the correction. I'm going to be like, but blah, blah, blah. And you're going to be like, because you've been using Mongo like an idiot.
Yeah, it's your fault. No. I don't it's totally natural, right?
Well, it's not natural. None of this is natural.
I do almost feel like it would be good to start off with like maybe AJ can go over like the pain points that a lot of people raise up, and then you could work on dispelling those pain points because for whatever reason,
too, like what everyone's experience level is in this podcast with MongoDB and SQL.
I have not used it in production, but used it. That's what we used when I did the boot camp way back when, like 6 years ago.
Love it.
So.
Yeah, I come from a pretty heavy SQL database, MySQL, Drupal, that kind of experience. I've used Oracle, SQL Server, over the years, various versions of a standard SQL database. I did mention to you, just for learning purposes, I took Mongo's free class on Mongo for Node developers, a few years ago. So I got a little familiarity. Now I have worked with quite a lot with Apache Solr, which is sort of the same. It's more of a key value store that you can put JSON in, I guess, as one of the options.
No SQL, love that. Yep.
And worked a little bit with, Form.io, the guy we had on last week, Travis Tidwell, a little bit, but that's pretty transparent. So, I'd say 99% of my experience is SQL.
Love it. Yep. I think that's super common too. And what about you, AJ?
So I've spanned the spectrum a little bit, obviously, because of my age. I started with SQL because, quote unquote, NoSQL did not exist for a few more years.
Yep.
I thought the NoSQL thing was just super cool when I think there was a presentation on it in a Python meeting back in, 2008, 2009, maybe 2010, but like right in that time frame when it was the big buzzword that was like, it was the blockchain of its day, right?
Right. Totally.
And
it's web scale.
Yeah. That's when that like the Is It Web Scale website came out and stuff like that. Which hilariously, isn't that the site where no matter what you put in, it says yes, except if you put in Mongo, it says no?
I do not know, but
there's a website funny. That's something. It's a parody site that's something like Is It Web Scale, and you can just type in gibberish and it'll say something like it's basically like a magic 8-ball. It always gives positive answers unless you type in Mongo, and then it says absolutely not ready or something like that. So it's some sort of troll site.
Funny.
I think it's isitwebscale.com. Hopefully that's not a dirty site.
Hopefully, cross your fingers. Well, I want to
because they get bought up. They get bought up and then they get turned into dirty sites. If you let it expire.
Just put ads on it. That's hilarious. Well, I want to say too, like everyone's experience here, I think is pretty common, right? Like Amy's, yours coming out of boot camp. I think teaching MongoDB is a super common database out of boot camp. And a lot of times what I'm seeing too is people like learned it a couple of years ago and they haven't really touched it since. And I want to touch on some of the upcoming changes that have gone on that you probably don't even know about. So that's awesome. And then
I should say too, and I did play a little bit with Stitch, which is pretty cool.
Yes, absolutely. Yeah. Super excited about that too. I know that no one knows about that one either, which is great. And then Steve and AJ, your stuff too is like super common too, right? Just coming from an SQL background, like.
And I use CouchDB. And I used just plain JSON files all the friggin' time.
Yes.
And I used, what's that thing that's not Berkeley DB, but it's Google's thing that's basically Berkeley DB?
Dynamo?
What?
No, AWS is Dynamo. Never mind. I'm thinking something else.
No, the little one. The one that's like in Chrome and like in a bunch of other stuff.
SQLite?
No, not SQLite, although I'm a big fan of SQLite. Love SQLite, love Postgres.
Yeah.
The two most advanced databases on the market with totally opposite ends of the spectrum. No, the Level DB.
Oh.
The one that everybody's building like their little embedded databases on top of that, where SQLite is not the right tool for the job or is difficult to compile or whatever.
Totally. Yeah, that makes total sense. Yeah, no, those are great. Those are awesome. So I think those are like totally great. So it sounds like we're all over the map on it too. It sounds like everyone's got a little bit of experience with it. Obviously, everyone's heard of it, but it sounds like people haven't really touched it maybe for a couple of years or kind of like haven't been paying attention to it, which I think is, again, super common too. But yeah, I don't know. Should we jump in? What should we talk about first? We could talk about, maybe we could talk about some updates on it, or we could talk about.
I think we should highlight a little bit what the job of a database is.
Oh, that's a great place to start.
Well, because so with the whole NoSQL movement that's was back in that time frame, it was really misleading because it was posed as you're either pro SQL or you're NoSQL.
Right.
And really, this is a broad spectrum. You've got key value stores. You've got indexed binary JSON, which I think is what Mongo is.
Yep.
You've got hybrid databases like basically every SQL database that people use, meaning Postgres and MariaDB/MySQL, are hybrid databases that have NoSQL as well as SQL. And then you've got document databases like what was CouchDB. I don't know if it's still called CouchDB. But, and each one of these things serves a different purpose. So I think maybe an overview, if you would, journey that.
Totally. That's a great one.
What's going on in this space and why? Why are there 6 different kinds of databases?
Mm-hmm. Well, MongoDB came about, right, because it was trying to solve problems that with like scalability and working with the data directly. Yeah, I guess we can give a quick overview of because you touched on key value stores, which are basically just like an example that would be, oh my gosh, I'm blanking on it. What's
LevelDB, BerkeleyDB?
Love it. Level. Yeah. So that's just accessing key value pairs, but like accessing deeply nested data, you can do, but it's more challenging. It's not natively going to do that. Also, key value stores, generally speaking, are more in-memory type databases too. So if the server gets shut off or whatever, that data gets lost, but it's for really quick retrievals.
That'd be your Redis. Well, no, Redis has backup as well.
Yes, that's actually what I was thinking of too.
Memcached, I think, is key value. But you've got things like BerkeleyDB and LevelDB. BerkeleyDB was the basis of MySQL for until MySQL 5 or 6 or something. So
yes, I guess I don't know much about the history of that one too. I'm still learning. There's so many databases out there. But the thing is too, I think we can all agree that storing data is one of the most essential parts of any business and persisting that data. And every application's using it. And we're seeing a massive increase in the amount of data that we're saving and who's working with that and what the purposes of that data being persisted are. And I think that we're seeing massive specialization in why those databases with that huge increase in just data needs from businesses. And I think it's important too, having the flexibility based on the needs of your application, what kind of database you need and how to tune it based on your application. And I agree, it's totally overwhelming. It's confusing. I work for MongoDB and there's a lot of people who are working in that document database space right now. And it's hard to even tell what the differences between those are, right? Just specifically.
The document databases are one where I think they are a very niche, document and key value, I think are kind of on the niche ends of either you're going to have to build a lot of stuff or you literally want to exclude a lot of stuff on purpose. And I feel like Mongo and say Postgres are kind of in a similar space with different approaches. One is the schema-ish approach. Mongo is schema-ish. And then Postgres is a combination of schema-full and schema-less because you can have schema-less binary. Well, they even now have schema-ish JSON stores.
Oh, funny. I didn't realize that. It's going to be flexible. And yeah, we people may not know this too, but I think when people think of MongoDB, they think schema-less, but we call it flexible schema, right? You can define how much control you want to have over your schema on your database. For example, with RDBMS, typically you have to, every column has to have a defined schema and rules surrounding that. With MongoDB, you can enforce those rules as much or as little as you want. So some columns, right, you're making a form, everyone needs to have a first name, last name, and an address, but a credit card number is optional or whatever else you want to be saving, right? So you can be more flexible with that schema.
I'm going to argue that you have the same flexibility with SQL database, but the SQL heads that come out of the pedagogy of the 1960s, it's kind of part of the religion of SQL that you should never have an untyped type.
Yes.
It's certainly, you have the flexibility, but I think you get a lot of angry old neckbeards in the community that when you choose to use a SQL database in a schema-ish fashion, they would yell at you. And I think that's mostly gone away. Because now, Postgres, you can have the hard schema, but you can also have schema-ish with the JSON H store. I don't know if that's the right name of it. Whatever.
Yeah, I know what you mean though.
But I think you get flexibility in both, but it's more marketable in something like Mongo because it doesn't have a tradition of neckbeards screaming at you for,
these are the rules and get out of here if you don't follow the rules.
My apologies to the neckbeards.
We love you, neckbeards. Please be kind to us, okay? Can I give a specific example too of when flexibility is important? So I talked last time about my IoT kitty litter box, right? I think IoT is a great example of when a flexible schema is actually a great use case. So for example, I was prototyping out my box and I added a new sensor to determine when the door was open or not for maintenance mode. And I was able to easily update my time series schema with that new data because I didn't really care about my old time series data. Like it's old data anyways. Great, who cares? I could have optionally gone through and like nulled it out or whatever, but whatever. Time series data expires, gets old quickly. And that was a good use case for having a flexible schema on my sensor data.
I'll hand it to you. Like, unless you made it a JSON store field, you would not, your database would not like you suddenly changing all of the columns.
Oh, totally. Yeah, exactly. And so I was able to like build it faster and stuff. I do that. But like, yeah, and coming from like that legacy RDBMS or relational database management system or SQL databases, much easier to update and fix. And it didn't end up being a big deal. Even if I deployed that to production, you could, like, working with the product team, you could argue that wasn't something that you need to persist long term.
So it sounds like you do put, like you said, well, the old data, I don't care about it. So you're saying, well, because the front end isn't going to request this data,
right? I
can just update stuff, and the data model basically is broken. Like it would cause a serious critical failure, like try catch, throw error, explode. But you're just saying, well, I don't care about the old data, so I don't need to invest the time to make it fault tolerant against looking at data that I know personally I'm not going to look at again.
Totally. And you could totally run a migration if that's important. But for like the use case, I just have a dashboard that shows the last 7 days of data. And for my unique application, that's totally fine. That's acceptable. Yeah. Yep, absolutely. So it depends. I think the point is, like, this all boils down to is like with our SQL, you have like the rules you have to follow, right? Which are like well as researched and established and great, but they're pretty inflexible. And you can get as flexible or inflexible as you possibly want with SQL or no SQL, excuse me. And particularly with MongoDB, based on the unique needs of your application. The other point I think it's really important too, and I would love to come back again and talk about this in greater detail, but it's with data modeling, right? With like a traditional SQL database, there's normalization, right? We typically normalize in the third form. And what that basically means
is... But Joe, what does normalize mean?
Yes, exactly. So normalization basically means we're splitting up data into separate tables. And we're doing that so we don't have to repeat data. We have to like put the same data in the same table. We have to have repeated data, and that would cause more data, and we have to do more updates, more chances for fault tolerance.
So I'm going to give people an example of this. If you think about a spreadsheet that you have in Google Docs or, heaven forbid, Microsoft Office, a contact list, the city is going to be repeated 100 times. The state is going to be repeated 100 times. Some of the other information that's in that spreadsheet is going to be repeated. Normalization is you say, well, I'm going to create another spreadsheet where the ID of the state is 1 through 50, the ID of the city is 1 through 50,000, and I'm just going to link in that number to the original spreadsheet. That's essentially what normalization is. And this solves the problem that Joe's talking about, the redundancy issue, or we don't want to store excess data, or heaven forbid, I think the real problem is when you go to update data, needing all of the previous historical records to be updated too. You fix a spelling mistake on a city, you need to go update it everywhere that you ever referenced a copy of that city. Whereas if it's normalized, you update it in one place, the ID stays the same. The other problem is cyclical data, which, if you can't JSON.stringify an object, it takes a little bit of thinking to figure out how you'd put it into a SQL database sometimes.
Oh, totally. Yeah, absolutely. Oh, totally agree. And I want to say though too, like I get asked this all the time when I talk about MongoDB with normalization, because the number one thing I see devs coming from SQL to NoSQL, particularly MongoDB, is they want to model their data like they would when they normalize it with an SQL database. But even still, like the big reason that people always give is like we're repeating all that data. Like normalization isn't even an anti-pattern anymore with SQL databases. Like you see people normalizing in SQL anyways, and that or denormalizing, like doing repeat data.
And it comes down to trade-offs and benefits. Like how much application do you want? How much application logic do you want to have control over the data? And for example, migration, because sometimes it's easier to write a migration in JavaScript than it is in SQL.
Absolutely. And the biggest thing is performance, because joins are really expensive and slow.
For sure.
And if you can normalize...
Ding. Yeah, that's exactly what I was thinking. It's always the most expensive thing is the joins.
So if you have a really slow database, one of the biggest things you can do is obviously index. But if index isn't working, you normalize or denormalize the data. So you're just repeating it in there to get super fast performance. So you don't have to worry about joins anymore. But that's a benefit you get out of the box with MongoDB. If you're designing your schema by embedding the data in there instead of doing expensive joins. And I always see people wanting to set up their tables in MongoDB with separate tables like they would normalize in a traditional SQL database, and they're not taking advantage of the embedding you get with MongoDB.
I mean, that's something I've wrestled with in the past, whether, I was working on a site that used Apache Solr as our data store. So again, it's not apples to apples, but it's similar.
Totally.
Is that, okay, so basically what you're saying is I have to update this whole record. If one part of that record changes, where it was SQL, I could just update the small part that needed to be updated. So that seems to be a sort of trade-off. So what's the benefit for having the document, database as you have it now, where you have to update an entire record?
Yeah.
Do you lose some of that advantage, or how do you address that?
You could potentially be updating multiple documents with MongoDB if you're denormalizing it and keeping it all in the same table. But that's a good code smell for a MongoDB document-based database. Yeah, and it depends. I'm going to say this, you're going to hear me say this a lot today, but it depends on the needs of your application. So I think there's no one size fits all, but it depends on what you're doing. So like, for example, maybe you are a read heavy application, and like it makes sense to just embed everything in a single document. So you don't have to do those joins. You just do a single read on a single document and get all that stuff out. Or sometimes MongoDB has a 16 megabyte per document limit. So maybe you have too much data that's over 16 megabytes. Then you actually need to split that up into separate tables. Like that's a good reason to start splitting that data up into multiple documents. But it depends.
Holy crap, though. I mean, if you've got 16 megabytes, how can that be performant? Because if it's got a scan, table scans. How do table scans work in something like Mongo?
Yeah, I'm not exactly sure the technical details. I can get information about that though. But table scans should be avoided at all costs.
Well, obviously, I mean, always. Yeah. But when you have so much data, like table scans, it seems like the more data you have in a table, the more likely you are to need to table scan. And the obvious question needs to be, well, what's a table scan? Table scan is when you have to do something where you can't easily index. Yes. You can't find something by an index. So for example, if we want to look up the city and state, I don't need to check every single row of the table. Like, does it match P? Does it match P? Does it match P? Oh, it matches P. Does it match PL? Okay, does it match PLE? Does it match PLEA?
Can I give a real world example of this?
Yeah, go ahead.
That'd be equivalent of using looking up a resource in a book. So index is like just looking up the table context and finding the page number for what you're looking for, right? It's just page 64 takes a second, right? Table scan is like, I have to read every single page in that book in order to find that resource that I'm looking for.
Excellent. Much better example. Thank you.
So in other words, you're indexing on the fly instead of indexing behind the scenes and building an index. You're basically having to go through the indexing process all the time instead of building the index behind the scenes and then just querying the index.
Yeah, absolutely. This is super cool. We just came out with this too. MongoDB in our Atlas, we have a schema advisor or index advisor. So if we start seeing that you're making queries a lot on this thing, we're like, hey, dude, you should probably start indexing on this thing because you're using it all the time. But yeah, and it depends. And just like with SQL though, your indexes should be based on the needs of your application. Because too many indexes will actually slow down.
Indexes, and particularly indexes slow down writes.
Yes.
It's kind of like you get a 10x trade-off in either direction. Your writes are 10 times slower, your reads are 10 times faster, or maybe 100 times faster.
Yes.
Your reads are almost infinitely faster. But your writes are not infinitely slower, but significantly slower. And you're taking up more space on the disk.
Absolutely. Yep. Because you're going to be living in memory. We have to store all that somewhere, right? But yeah, in indexes too, it slows down because every time you make a write, you have to re-update your index as well as the record you're updating. So it's like more things you have to update, which slows down the write performance. That depends. Like if you're a site like Twitter, where one person's writing one tweet and then 30 million people are reading that single tweet, you obviously want to be...
And they don't have an edit button.
Exactly, yeah. Yep.
So the writes, there is no expense of additional writes because there is no edit.
Exactly. Yep.
Which is something you can implement in lots of different types of databases. Is doing log-oriented writing rather than, editing a database is just a bad idea. Don't ever edit a row. I don't know how you feel about that in Mongo, but you lose your security trail. You lose.
Are you talking about like mutability with your records?
Yeah, mutability of records is like, if you can avoid it, I'd say don't allow someone to ever do an update. Just write a new record.
Yeah.
Write a new record with the same quasi ID and then select by which record is most recent.
Oh, totally. Like you can obviously update MongoDB records, but I love that though. If you want to build a mutability into your database, that's not a problem, right? You're just versioning or persisting.
Does Mongo have any sort of like built-in versioning? That's something that I haven't seen in SQL databases. I don't think.
No, but that would be that'd be a schema design. So there's a design pattern where you just like mark the version number as a separate field in your document. So you could totally do versioning with metadata on each document.
Okay.
It depends. It depends. Like out of the box, no, but you could easily program something like that using a schema design.
Right now, many of you are stuck at home, but eventually everything will open up. All right, listeners, let me ask you a question. Wouldn't you rather work from home instead of a cubicle or a noisy open office? Need to negotiate with your team and convince them to let you do it? Well, I have the perfect book for you. It's by my friend Will Gant. It's called Remote Work. Get a job or make a career working from home. He's a proven author, software developer, and professional consultant with over 20 years of experience in a variety of roles, and now he wants to share his trade secrets with you. In Remote Work, you'll discover how to save more time, money, and mental energy each year, how working remotely can give you and your company a competitive edge in the market, managing your physical health, mental health, career goals, and relationships. You'll also get the ultimate list of tools and resources to help you transition into working remotely, and much more. This is the perfect time to test out if working remotely is for you. And if you enjoy the freedom of working anywhere you want, then you can pick up your copy of Remote Work on Amazon today or click the link below.
So when it comes to overriding, does it's been a while since I've worked with this, so I can't remember. But does it work that if like every record has a key ID value that uniquely identifies that record?
That's right.
And if you send the ID, it overwrites the record. If you don't send an ID, it generates a new one? Or is that something you sort of have to build in yourself?
It depends. So like you can do a upsert. Upsert will do a insert if it doesn't exist or a update if it finds it. You can do inserts that'll just do that or updates. It depends.
You specify the unique key for your record as compared to something that Mongo generates behind the scenes for you?
Yeah, so that's one. You can do updates based on anything. By default, we recommend ID to enforce uniqueness. It's going to really help to make sure you're not blowing up other things. Like, for example, you have 30 million people named Joe on there and decide to do, change every field that has a Joe, right? You could potentially be modifying data you intend to update. Yeah, that's by default, we index that field. So it's really easy to make changes if you're querying based on IDs, but you can easily add additional indexes based on your application.
Sure. Okay.
Yeah. And I recommend to people, I see a lot of people too trying to change the default ID, which is typically an anti-pattern. I would avoid changing that, because I want to make it my unique username. Like, cool, awesome. But you and this happens with RDBMSs too. Like using custom foreign keys is it's a risky move. You want to make sure that you're linking based on uniqueness, and using the out of the box IDs is a really great way to do that.
Yeah, you don't want to mess with the default. What I think in SQL, like an auto increment type field or some sort of ID.
Totally.
You're using, you wouldn't want to screw with those numbers. You don't really have to.
Auto increment is a bad idea in today's world.
For everyone.
Yes, it really is. Like UUIDs are, I don't know if MySQL's up to speed, but Postgres, very, very easy to have auto insert UUIDs.
Yeah.
And
those are generated by the database?
Yeah. So it's, you can get it generated by the database. Of course, you can create it in your application layer, but you just import the crypto module, and then you do crypto.uu, select crypto.uuid to debug it, to see it manually in the console. And then you add something like default UUID.generate something. I don't quote me on that. I'm saying it wrong, but it's fairly simple like that. You just say the default field is generate UUID.
Right.
And then it calls that function if the field is empty.
Yeah.
Because you cannot horizontally scale with an auto incrementing integer.
Totally.
And you will completely bust your application as soon as you need to go on more than one node.
People do not think about that when they scale up, right? You have two separate sharded nodes who are doing auto increment. They could start doing the same number. What if you delete one and edit one? It becomes a mess way faster than people think it will be. It makes sense to their human brains, but it doesn't make sense for computers to do it.
It doesn't matter what database you're using. It doesn't matter if you're using SQLite. Do not use auto increment. Use UUID.
Yeah, I love that. Totally. Everyone, we need to say that louder for the people in the back.
So do not use auto increment. You will hate your life, and your past self will vex you.
Exactly.
Use UUID.
I love that. No, I totally agree. The other thing too, I think people don't know much about, and especially for newbies coming to NoSQL, is scalability. So we touched on a little bit on horizontal scaling. I'd love to talk a little bit more about vertical and horizontal scaling.
Do we need Amy to ask what horizontal and vertical mean? Her internet's broken. I'll channel her spirit. I'll channel her spirit. Okay, you channel her spirit.
We just scared her off. Oh, no.
Hopefully she'll come back. But yeah, so what is horizontal and vertical scaling? Oh, I'm so glad you asked, spirit of Amy.
Wait, can I take a guess real quick?
Yeah, please. Oh, that'd be great.
Okay. Now, I believe the horizontal is adding more resources, like either dis or sharding, I think is the term that Mongo uses.
Yep.
Am I getting that correct? So
yeah, it sounds close to another word that we probably won't mention on here.
Yes, I won't mention that word.
Sure.
Basically, you're creating a larger base for your data to reside in, so that's why it's considered horizontal.
Yes. Wait, can you say it one more time? It has one more time.
I said I'm thinking, I'm very visual, so I'm thinking in my head, if you're sharding, you're creating more disks for your data to reside in, so it's larger base is how I think about it.
Yes. Yeah.
For your data to reside. So that's a good description for horizontal, right?
Let's tweak that because you said something that's ambiguous there. It's more disks.
Yes.
Yeah, it's more disks, plural.
Independent disks. Yeah. Yep.
Yeah.
And more nodes.
Yes.
Yeah, exactly. More places, buildings, however you want to describe it, but it's a bigger area, surface area to be able to store your data.
Yep.
Yeah, not more resources on a box.
Right. It's more boxes. Resources. Yeah, exactly. Right.
Yeah. I want to talk about like a specific example. So say I'm running a traditional RDBMS or SQL database, and I run out of space. Like, my 3 terabyte hard drive's running out of space. What do I do? So this is, again, not true for all RDBMSs, but for a lot of them, you have to vertically scale. And what that means is you stop writing traffic to that original server that's running out of space. And you go and buy a bigger, like a 5 terabyte hard drive, whatever. And then you have to go and move all that data to the larger database. And then you start redirecting traffic to that new one. So it's confusing. You could potentially lose data. There's maybe downtime. There's ways to mitigate this. But vertical just means you have to go buy a physically larger database or larger server with more space on it, which is fine, right? But horizontal means if I run out of space on a MongoDB database, I just go and buy a separate disk, a small, cheap one, and I just start routing traffic to that new one. There's no downtime. We start just querying and moving data around horizontally. And you can buy as many small nodes as possible, because you might know this too, just like instinctively, but hard drives are pretty, like data's cheap right now, but buying really, really big hard drives gets expensive quickly. Right? So it's much cheaper for us to actually buy many smaller hard drives than one huge one and doing that migration with the vertical scalability.
So where does doing stuff like master slave come into play?
And I prefer to use leader follower.
Leader follower. I wasn't sure what the correct term was anymore.
I know. No, it's good. That leader follower.
It's become politicized.
Yes, very much so. But the idea is basically that you have one sort of lead disk that redirects reads to other disks.
Yes.
So that for load balancing purposes.
Oh, absolutely. So basically what happens is the sharded clusters, they kind of sit below, but there's a leader MongoDB server that's taking in all the requests, and it's kind of figures out, like, it knows where all the data is because you shard on an indexed key. So it can quickly figure out where the data is saved. For an example, I think a really cool use case for that is sharding based on geolocation data. So if I have a global database, I can save all my data for Australian users near a sharded cluster that it sits really close to Australia. So that data for them is super fast. And I can shard for Chinese markets and European, right? But that master server routes all the traffic requests to the correct sharded node. It's hard to describe. This is one of those things that's so easy to show a picture of and it makes sense. I'm trying to tell the story of how it works, which is a little bit harder. But I hope that makes sense. The other thing, too, I want to make a note of is a lot of other document databases don't actually shard horizontally, and make sure you're looking to make sure that database does that. I think just because it's NoSQL doesn't mean that it has sharding baked in. Always want to check that out, because otherwise you have expensive scalability issues if you have to do vertical scaling. And potentially Amy's back.
Okay, so
restarted my modem. Good now.
You channeled your spirit while you were gone.
Oh, no.
You asked very, very sharp questions.
You did, and you were good.
Thank you.
Was your cat jumping on your computer again, or is it something else?
Gosh only knows. I mean, we had the horrible storms last week and lost like all electricity and internet. So I don't know if it's left over from that, but it appears to be better now. Knock on wood.
Oh, that's awesome.
So we've established the horizontal is adding more boxes, disks, plural, bigger base, and vertical is increasing basically the capacities of the boxes that you have.
Yeah, and MongoDB or a lot of NoSQL databases have NoSQL databases. And again, a lot of RDBMSs do too, but traditionally they haven't. I think we're seeing more, across the market, seeing a lot of hybridization and seeing that kind of adopted by more databases.
Yes, that would make sense.
I'd love to talk about ACID transactions too. That's the other thing that comes up a lot with MongoDB and RDBMSs.
You would like to talk about ACID, wouldn't you?
Does anyone want to drop some ACID? I'm kidding. But ACID transactions, so it's atomicity, consistency, isolation, and durability. It's an acronym, right? And every single RDBMS is, well, not every, but a lot of traditional legacy SQL databases are ACID compliant. And that basically means that if I put a thing in the database and it's going to either fail and roll it back, so like nothing happened, or it will succeed, and I'm guaranteed to get that success. That's the TLDR of an ACID transaction, an ACID compliant database. I think that this actually is a common misconception, though, that MongoDB is not ACID compliant, and that's actually not true. We now support ACID transactions on sharded clusters, so you can do massive global ACID transactions on a sharded MongoDB database. That means and you could do that for multiple things, right? Like by default, each document is ACID transaction, like out of the box, but you can now specify, like, I want to do this update, a delete, two queries, another update and delete. And that whole transaction needs to succeed. And if it doesn't, it'll roll everything back for you.
So I think there's a distinction for me.
Yeah.
And for everyone in the world, I guess not just me, otherwise it wouldn't be worth talking about. Between totally. A transaction, well, I don't know. Like what I think of as an ACID transaction is almost now a dirty word. Again, it's like one of those things from the neckbeards of the 60s.
Yeah.
Like we don't need ACID transactions. Those are bad. We need eventual consistency. Mm-hmm. And I don't see how can you call something an ACID transaction if it works across multiple... I guess if you don't work across multiple rows, if you don't have joins and you just shove everything in one row,
yes,
then you can have ACID transactions because you don't have multiple tables to consult. So all of the data that's necessary for a lookup exists on the node at which it's being looked up, guaranteed. Is that?
This is the same question I had like a while ago. Like by nature of like where we're at now, this argument is kind of like a little bit invalid, which is what AJ is saying, just by nature of us building like distributed systems.
Totally. Yeah. And like, it may not necessarily be on the same node. Like with MongoDB, it could be across. The data could be saved on multiple nodes potentially, right?
Well, saved on multiple nodes, but for ACID to work, there has to be a single source of truth. There has to be not just a leader, but a master. Because it has to not just be saying, come follow me. It has to be saying, do as I say or die.
Oh, totally. Yeah, and I'm not exactly sure all the technical like details that's implemented, but I like we're keeping track of those records and can undo that transaction on each, and the guarantee that those are being undone across multiple nodes. The key too, I think, is with databases, you have control over the amount. Like if you want eventual consistency or you want it guaranteed consistency, like those transactions will come back after all of the replicated nodes have gotten that data updated, or if we only care about the leader for those replicated nodes or whatever, right? You can decide how much control we want over how that data is, like how guaranteed we are that data is persisted. Number one consideration there is performance. Obviously, if you need to make sure more things are being saved, that's going to take longer for that app or that transaction to actually, or that query or whatever to actually take place. It depends on your application. What do you need? What's important for your application?
Not ACID.
Yeah,
I mean, like even a bank, right? Like, because I think the example, the canonical example for ACID is like, well, you need your bank transactions to go through.
Right.
Your bank doesn't use ACID. Okay, your bank makes sure that those transactions are lazy evaluated. They are eventually consistent.
Yeah.
Have we talked yet about like the CAP theorem? Because we're kind of talking about that too.
Oh yeah, I guess that would be good to pull up as to why you have to either choose ACID or eventual consistency.
Yeah, so that's kind of what I was like referring to. And MongoDB,
CAP theorem, Amy?
So CAP theorem is there's three things. There's consistency, availability, and partition tolerance. And really, so you can only pick two. But I guess what I was saying earlier is nowadays, you really, because of distributed systems, you're always going to pick you're never going to pick one of them. But it was my understanding MongoDB favors consistency and partition tolerance, right? So they would be like CP. Because usually people either say it's CP, AP, or CA.
Mm-hmm. By default, it does. But you can totally tune it to be whatever one you want. So yeah. So technically, yes. But you can do it. You still have flexibility over.
So a lot of times choosing a database is not necessarily even always about do I want SQL or NoSQL? You'd want to figure out which database favors the parts of this CAP theorem that you're looking to hit. And some databases are faster on reads, some databases are faster on writes.
Right.
So
yeah, an example, right, for the banks, you obviously want those to be consistent. If I give you $100, I want to make sure that's being put through, right? For everybody. But for someone like Twitter, having that consistency is not that important. If you see a tweet listed above another tweet and another user sees that in different order, not a big deal, right? As long as you see that eventually, it's probably fine. So they're favoring speed as opposed to perfect consistency across all users because it really doesn't matter for them. The data is moving so quickly through the system.
Yeah, and it's just nowadays, we have to have partition tolerance. So
absolutely, yeah, and that's a good point. I mean, obviously with sharding with MongoDB, it's partitioning is a core tenet of what you could do with MongoDB.
So I actually I was studying a little bit of this a while back before my most recent job because I just wanted to brush up on all the stuff for the interview process. But so the other databases that I have written down here that are CP, meaning they favor consistency and partition tolerance, would be Memcache and HBase. And then the ones that favor AP, availability and partition tolerance, Cassandra, Couch, React. Is it React? React? I don't know how do you pronounce that.
I don't either.
Or just
I've never heard anyone say it out loud. I just read it on Hacker News.
And then do I have anything for... I don't have anything for consistency and availability because, like I said, nowadays, that's just not really a thing because we need partition tolerance so we can be building distributed systems.
Totally. Yeah, that's it's basically essential for any modern web application to be able to partition. Yep. Yeah, that's interesting. That's a great list. I love that.
So, Joe, I'll throw in this question. I don't think we've addressed this too much, but obviously you've mentioned that you always want to use the right tool for your needs. Yeah. So where are use cases? What are the best use cases for MongoDB that you've seen or that you're aware of versus what cases would MongoDB not be a good fit?
I may be biased here, but honestly, MongoDB is a good general purpose database these days. And I think it's because it has strong defaults and you can be as flexible or inflexible as you want. Yeah. So being able to enforce schemas, great. If that's a need for you, cool. If you need those ACID transactions, great. Go for it. If you need to scale up, cool. It's a great use case. I think some of the use cases I see get used a lot. And again, it can be used for a lot of things, but I see it a lot for obviously IoT, which I talked about last time I was on. E-commerce sites is really huge. Gaming, we see a lot of people in gaming using it. You see it for just quick data. Sometimes I just need projects and I don't really care about scalability. I just want to get data in and I want to get that data out without having to think about it much. You can do that too, right? Yeah, those are the big verticals we see. We're seeing tons of banks using us though, government agencies using us. Lots of different people are using MongoDB for a bunch of different use cases these days, especially with the updates we made recently.
Yes, okay. I have another follow-up question too. So explain to me the case. Maybe somebody was on MongoDB back 5 years ago and the application grew and maybe they had on-prem, they actually were managing stuff on-prem and they're wanting to migrate to the cloud now. So walk me through the different services you offer. What if I wanted to go into leverage Google and leverage GCP, but all of my data was living in MongoDB and, obviously GCP offers different NoSQL solutions. But what if I wanted to stay with MongoDB? Then what do I do?
So people probably don't even really know this, but MongoDB has a database as a service cloud option. We call it Atlas. You should totally go check it out. Actually, I can leave with you guys a free code to get like $100. Just my Joe K100. Get $100 off the cloud option. We have a free tier that'll be free forever. I've been using it forever. I've never gone over on the free tier. It's amazing. But the cool part about it is that Atlas, we're agnostic. So I think a lot of the database competitors who are doing document-based databases, you're like locked into that vendor. You can't change out. You can't move from everywhere. But MongoDB and Atlas in the cloud, we support GCP, Azure, and AWS. So you can host all of your data in whatever database service provider you're using. And there's a bunch of huge advantages of that too. Yeah, it's just awesome. And there's a bunch of other stuff in there I'm not even like touching on. Like the thing I'm most excited about is if you're hosting in the cloud, you get like our most cutting edge features. We just unveiled like our schema advisor, our performance advisor, right? We're looking for indexes.
Wait, when you deploy to the cloud, you get our most cutting edge features. To me, that sounds scary because what I hear is you get our least stable version.
I should say, like,
can you clarify, please?
Yeah, absolutely. I mean, like, so obviously versioning, you still like do upgrades to versions. Like if you're running a production app, we're not going to upgrade you to a major version bump automatically. But you will have access to do those upgrades before you get those on-prem upgrades. Like we roll them out first. You can like test them out. So it's not like you're shoving down your throat. It's just like, here it's here.
So is that a beta thing? Like I can opt into this beta, or is that like, because I mean, I'd prefer it to go out to the open source community and let other people deal with the problems for 6 months first.
Totally. Yeah, absolutely. I think it's a beta program.
I'm going to get crucified for that, but that's the way it is, right? As you know, as a business decision.
Oh, totally. Yeah, absolutely. I think we have a beta program. I'm actually not exactly sure that works, but it's an opt-in thing, right? You get to choose how, like, if you want to stay at a version number, like many versions ago, cool, not a problem, right? Not a problem. But like we have a serverless option on top of our database. We have like things you can access. Like we have a new GraphQL endpoint. Since it's MongoDB is a document-based database and we know the data types of each of those different fields, we generate a GraphQL schema and endpoint automatically based on your data. So you can do CRUD operations with Graph. It's like out of the box, you can just start querying it. But like things like that are available only in the cloud right now. I think they're so cool.
Okay, so it's not just like the latest features. It's like the business. You know, you get more enterprise features.
Yeah, and all those are free though too. Like we have charts, and so you can like do data visualization for free with your data. Embed those in your applications. You can do a bunch of cool stuff with that too. Yeah, other just serverless options, building a REST API. A lot of times, what I'm doing now, I just use our service and I just build a REST API in the cloud, and I don't even need a server anymore. A lot of times, my server is just doing basic CRUD operations of some data. So a lot of my applications, it's just easier just to have like a serverless interface to my database. And we do that super easily.
And then now from a GUI standpoint, I'm always big about the database GUIs. I mean, I can do command line as well as I just like the GUIs. So you have one called Compass, I believe is the MongoDB.
Which is great for newbies. If you're new to databases, it's very visual. We kind of help you structure queries, that sort of thing. So we have Compass. We still have our CLI. I'm still a CLI guy. I like scripting it. I like having access to that, right? We can still access the REPL, no problem, right? And of course, you can access it in the cloud too through like the Atlas console or whatever, right? You can just click around it and like make changes in the cloud through the browser, which again, very, very beginner, user-friendly, super easy for prototyping, just kind of checking things out.
Cool. All right. Anything else you want to cover that we have not yet discussed today?
No, the only thing I'll say too is we touched a little bit on this again. I'm scheduled to come back to your podcast again to talk more about data modeling. That's more like, this is my 101 type content, but I'd love to get more into like 102 content. Because the number one thing I see people making mistakes with is like understanding data modeling for document-based databases, which is kind of it's this whole other thing, right? There's no rules and it's kind of, it's
let's do it.
Yeah,
let's do it.
No, that's it. No, that's it for today, I think.
Now, speaking of education, one more thing, and I've taken part in this before, and you guys were talking about it, is the MongoDB University. So a few years ago, it's been, 3 or 4 years, I went through the course on MongoDB for Node developers. And I know there's a couple different variations, but it was free. And I thought it was a pretty cool class because it took a number of weeks, and every week you had homework and an assignment, and then you had a final project at the end, and you got a certification, for what that's worth. But I thought it's pretty neat, pretty detailed, and there's forums you can ask questions and stuff. So anything else there you want to expand on that?
Yes. So that the university.mongodb.com is incredible. It's totally free. I went through that training when I got started as an engineer. It's like our internal training for technical training. It's totally free and open to the public, and it's super cool. We're making changes to it all the time. I just posted here. It's if you're new to MongoDB and you want to get started, we have an M001 course. That's basically the MongoDB 101, right? That's a great place to start if you're new to MongoDB and you want to learn more. And it's totally free.
Yeah, you got classes on what basic cluster administration, aggregation, performance.
Yes. Sharding,
Java,
data modeling,
JavaScript, .NET, Python.
Java. Yep. We can go as beginner as deep as you want to go with it. We'll take you there. The internals of indexing and we can go through all that. And it's amazing.
Good stuff.
Yep. Thank you for bringing that. That's awesome. Yep, absolutely. We just launched our developer hub too. I'm going to pitch that really fast too. But if you want to see like articles, projects, share stuff, learn about the community, but developer.mongodb.com is a great place to go to. Just launched it. And that's it.
All right. Good deal.
Hey folks, are you trying to figure out how to stay current with React Native? Maybe you heard the Chain React conference was canceled and you're a little bit sad about that. Well, I borrowed their dates and I'm doing an online conference. So if you want to come and learn from the best of the best from React Native, then come do it. We have people like Christopher Shadow from Facebook. He's going to come and he's going to talk to us and answer questions about the origins of React Native. We're also going to have Gant Laborde from Infinite Red and several of the panelists and past panelists from React Native Radio. So come check it out at reactnativeremoteconf.com. That's reactnativeremoteconf.com.
With that, we will move on to picks. We'll go in alphabetical order by first name and go Amy.
Oh, God. I'm not ready, but I'm going to hurry up and try to find something. Oh, my God.
Okay, while you're finding, we'll switch over to AJ. AJ always has things to talk about.
Lexicographical sort, if you didn't go alphabetical, but strict lexicographical.
Sorry, I couldn't do those calculations in my head. Is that IJ...
Yeah, capital letters sort before lowercase letters.
Gotcha. Well, in my defense, in Zoom here, you have your name in lowercase letters. So
well then I would sort actually after everyone. So I would go last.
Okay.
Anyway, so I've got a couple of on-topic picks, and then like not even a pick, just this happened.
Fun.
So first of all, I don't know if this is 100% true, but I talked before about the Ars Technica war stories, and there's a game called Ultima Online that was one of the very first online games that was hugely successful and got lots of users, and they claim that they invented the term sharding because there was a wizard in the game and it had like emerald shards, and so when they had to split up the lands to support multiple sets of users, they called it sharding. And then he didn't say like, and so we invented that term, but he said, yeah, so, lots of these people using databases these days, they don't know where the term sharding comes from. That's what it is. So Anyway, interesting episode to watch. And I mean, always the Ars Technica war stories are just amazing. I don't even know if they do it anymore. I think I'm just catching up on what they did years ago. But I love those things so much. Crash Bandicoot and Abe's Oddworld Abe. I don't remember what. Anyway, like they just go through a bunch of games that you've at least seen advertising for, if not played, and then tell the how it almost didn't work or the how it worked, but then was a failure commercially or whatever. Next,
those are so good though. I just watched the Crash Bandicoot one. Oh, it was incredible.
Yeah,
I agree.
The extended interview, the one that was like an hour instead of 10 minutes.
Yes, so good. Yep.
Just amazing. Freaking amazing. Yeah, I'm glad that you got to enjoy that too.
Mm-hmm.
The next thing, an oldie, a super oldie, way oldie, but a goodie. Your coffee shop doesn't use two-phase commit. And it kind of compares basically like Starbucks to Walmart. Like Starbucks, you've got you're taking orders and people sit and they get callbacks. So this applies not just to databases, but also kind of to programming paradigms like the callback idea or the async await idea. And then, versus you have lots of different registers, but each register finishes a task from beginning to completion while the customer is there, and kind of compares and contrasts that idea as it applies to data in a database. And then also some dude, Steve, added me to the Twitter list TypeScript. So I'm just going to give you a slow golf clap, Steve. Excellent troll. Okay? Excellent troll. Thank you, Steve.
That wasn't me, by the way.
It was me. No.
No, and I just, it hurts a little. Okay? Somebody who attack me like that publicly or privately, because I don't know if lists are even public. If I just get a private notification to someone to attack them.
I feel your pain, AJ.
I'm done.
All right, Amy, you ready yet?
I am. So I'm going to go with something I started on GitHub a couple weeks ago. And if anybody kind of like follows me, I really like to deep dive into things because while abstraction is great for moving fast, I think it helps you to debug when issues arise if you kind of know what's going on under the hood.
Yes.
So,
love that.
So as I've been diving into Kubernetes, obviously it is a great tool, but it abstracts away a heck of a lot. And so this is kind of a deep dive of like each step of your deployment, what's actually happening under the hood. So I will include a link for that and have a read. And then the other thing, it's been a while, but I am always looking for like healthy, different food. So in order to do my part in stimulating the economy, I've been trying to like, maybe treat myself on some stuff because I'm not really eating out as much, on things that, because I am fortunate enough to have, funds to do this kind of thing. All that to say, I purchased some like healthy keto cereal from the cereal school. It's very expensive compared to regular cereal, but it's also pretty healthy. It has like 17 grams of protein, 100 calories, and I don't know how many carbs, but obviously it's keto. It doesn't have a lot of carbs.
Is it good though?
So it's very good. It's very expensive, but it's very good. So this is a treat for myself. So that's going to be my healthy pick. And that's it for me.
Excellent, dude. Sorry, that was my Bill and Ted put there. So, and I think I'd mentioned in an earlier pick that they're doing another movie here, I think.
They are, yeah. Who knows when that'll be coming out though, but yeah.
Who knows how good it'll be, but it'll be a way to kill a couple hours at least.
Totally.
So I'm going to continue down the musical route that I've been going lately and go back to the 80s when I was in college. And I know some of the purists are not going to like me this, but I'm going to go with Pink Floyd's Momentary Lapse of Reason album. So for all Pink Floyd purists that are screaming at me, that's not really Pink Floyd, because it was the first album post Roger Waters. It's still an album that or CD or, MP3 collection, however you want to phrase it, that I listen to this day, start to finish, every day. Starts out with Learning to Fly. You got the Dogs of War. The fourth song on the Turning Away is my favorite guitar solo of all time by David Gilmour. And it's just there's a lot of longer guitar solos in this, but for whatever reason, this is one album that I really latched onto that start to finish, I'll listen to it on a regular basis. So it doesn't have the Roger Waters in it. So it's maybe not, real Pink Floyd to the purist, but it's still a fantastic album. Joe, your turn. What do you got for us?
Last and least, of course.
Oh, no. Not lexicographically.
Oh, I forgot who I'm speaking with. Okay, so I've been like trying to like not like, I've been too stressed out and I haven't been able to like read stuff. I've been trying to like take a programming break and like a social media break recently. But that basically means I've just been playing Animal Crossing New Horizons a lot recently. So a lot of that. But I do want to put a plug into MongoDB Worlds coming up, which I'll be speaking at. I'm actually going to be running the Twitch stream. That's on like June 9th, I think. We'll put a link in that though. But just go to mongodb.live and you should be able to see all the information on that. But I'll be on the Twitch stream, which is just twitch.tv/MongoDB. And if you want to check that out. That's it. That's all I got.
All righty. I believe that wraps up the show for today. So thanks to panelists. Thanks for Joe for coming on yet again. And it sounds like we will have Joe version 3 at some point in the near future.
Yes. Thanks for having me on. This has been so much. I always have a blast coming on here with all y'all.
Oh, yeah. We have a lot of fun. It's a hoot. So thanks for coming again, Joe. And we will talk to everybody next time.
Bye.
Bye.
Adios.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.